All right, GCSE Physics. Feeling that exam pressure? I get it. Let's tackle a big one together. Forces and elasticity. Forget all the extra revision noise. In the next few minutes, we're going to zero in on exactly what you need to know to smash this section and grab those top marks.
So have you ever really thought about how stuff stretches, or bends, or gets squashed? But the real question is, what does the exam actually want you to know about it? We're going to cut right to the chase and look at exactly what the AQA spec says you need to know. No fluff.
Okay, let's get right back to basics. The absolute foundation. If you want to change the shape of anything, I'm talking stretching, bending, squashing, you always need more than one force. Think about it. It's just common sense, right? You can't stretch a rubber band by just pulling on one end. It's impossible. Now, this whole process of changing shape has a proper physics name. We call it deformation. And it comes in two main types.
And this is the first big idea you've absolutely got to get. First up, we have elastic deformation. Think of a rubber band. You pull it, you let go, and snap. It goes right back to how it was. Simple. But then you've got inelastic deformation. This is like stretching a piece of blue tack. You pull it apart, and it just stays there. It's permanently changed. Knowing the difference and being able to define both of these, that is a classic guaranteed exam question. So get this locked in.
Okay, so let's focus on that first type, the elastic stuff. When something stretches and snaps back, it's not just random. There's a rule, a really, really important one. In fact, you could say it's the bedrock of this whole topic. And that rule has a name, Hooke's Law. Right, this is a big one. You need to know this definition by heart, word for word. The extension of an elastic object is directly proportional to the force applied. Simple enough, right? Double the force, double the stretch. But wait, there's a catch. Provided that the limit of proportionality is not exceeded. That last part is the key. It's the fine print. If you pull too hard, you break the spring, and the rule doesn't apply anymore. It's that point of no return.
And of course, in physics, a law means an equation. For Hooke's law, it's this: F equals K times E. Now listen up, this is super important. You have to memorize this one. It is not on the equation sheet they give you in the exam. You have to walk in knowing F equals KE. No excuses.
So, what does it all mean? Well, F is just the force, measured in newtons. E is the extension, how much it's stretched, and here is a classic exam trap, so listen carefully. Extension has to be in meters. They'll almost always give it to you in centimeters to try and catch you out. Convert it. And finally, K is something called the spring constant. Just think of it as a stiffness rating. A massive, beefy spring from a lorry suspension, that's got a huge K. A little slinky, a tiny K.
Okay, so stick with me. When you pull on a spring to stretch it, you're using a force and you're moving it over a distance. Does that ring a bell? It should. Force times distance is work done. And we know from, well, all of physics that energy can't just disappear. So the work you put in, where does it go? It gets stored right there inside the spring. And that's the key idea here. The work you do gets converted and stored as elastic potential energy. It's almost like you're charging the spring up like a battery. All that energy is just waiting, and the second you let go, whoosh, it's released, converting into kinetic energy as the spring flies back. Naturally, we need a way to calculate that stored energy. And here's the equation. And some good news, this one is given to you on the equation sheet. Phew. But, and this is a big but, don't relax just yet. Just because they give you the formula doesn't mean the marks are free. You have to know what every single bit means and how to use it without falling into the traps.
So let's have a quick look. E, that's our elastic potential energy, measured in joules. K, that's our old mate, the spring constant. And E is the extension, still in meters, don't forget. But look really closely. It's not E, it's E squared. I cannot stress this enough. Forgetting to square the extension is probably the #1 mistake people make with this equation. Don't be that person. Always square the extension.
Okay, theory's one thing, but you know your exam is going to hit you with practical questions. This is where AQA's Required Practical 6 comes in. This is how we take all this theory and see it happen in the real world. It's how we can actually test Hooke's law and figure out the spring constant for a real spring.
Honestly, the experiment itself is dead simple. You get a spring, you hang it next to a ruler. You add a weight, that's your force. You measure how much it's stretched, that's your extension. Then you just repeat. Add more weight, measure the new extension. And again, and again.
The actual practical work is easy. The real physics, and where all the exam marks are hiding, is what you do next. You plot a graph. And trust me, that graph is not just a bunch of dots. It is a goldmine of information. Seriously. Being able to look at one of these graphs and pull out the data is a skill the examiners absolutely love to test. So, let's unlock its secrets.
Okay, screenshot this slide, tattoo it on your brain, whatever you need to do. This is pure exam gold. 4 things you can get from this graph. 1, the straight diagonal part. That's Hooke's law in action. It's a picture of directly proportional. 2, the gradient, the steepness of that line. That is the spring constant, K. They'll ask you to calculate it. 3, see where it starts to curve off? That's it. That's the limit of proportionality. That's the point where the spring has been stretched too far. And 4, the area under the line, that represents the energy stored in the spring. Any one of those 4 could be a multi-mark question.
Phew. Okay, that was a lot, I know. So, let's boil it all down into one final checklist. This is what you should ask yourself the night before the exam to check you're ready.
All right, let's do a quick self-test right here, right now. Can you define elastic and inelastic deformation? Go on, say it out loud. Can you state Hooke's law word for word, especially that bit at the end? Can you grab F equals K, rearrange it, and solve for K or E? Can you use the energy equation without forgetting to square the extension? And finally, if I gave you a graph, could you find the spring constant and the stored energy? If you can honestly say yes to all of that, you are in a fantastic spot for this topic.
Look, if your brain is full and you can only remember one thing from all of this, make it the definition of Hooke's law. That one sentence is the key. Everything else, the equation, the graph, all of it, comes from that single idea. It's the core principle.
And just to leave you with this stuff isn't just trapped in your textbook. It's literally everywhere you look. The clicky mechanism in your ballpoint pen? That's a spring obeying Hooke's law. The massive suspension systems in cars, trains, even suspension bridges holding thousands of tons. It's all built on these exact same principles. The physics you've just revised is what makes the modern world work. Now go ace that exam. You got this.